Okay, so welcome back, and so now we're going to talk about another operation on a set, okay? And this is called the complement of a set, and it's denoted with this A with this apostrophe or this slash here, which is called A prime. We call this A prime, and A prime is what we use to denote the complement of a set, okay? So the complement of a set, by definition, is a set of all elements that is in the universal set, but not in the given set. Okay? So in other words, A prime, the complement of A, means I want all the elements that are in the universal set, but that are not in A. That's the definition of the complement of A. Okay? So here's an example. So I've got these sets. I've got the universal set that contains the numbers 1 through 5. Okay? And I've got this set A, which contains the numbers 1, 3, and 5. And then I've got B that contains 0, 2, and 4. Okay? And then I've got the set C that contains 1, 2, and 3. Okay? So now the first thing I'm going to do is let's look at A. A says A prime, or the complement of A. So I want the complement of A. So I want everything that's in the universal set, but that is not in A. Okay, so what's in A? A contains 1, 3, and 5. So I want everything that's in here that is not in here. Okay, so that means I have to exclude 1, 3, and 5 here. So that means 2 and 4 are in the complement of A. So the set is going to be 2, 4, and that's my answer. Now what about the complement of B? Again, I'm just going to apply the definition. I want everything that's in the universal set that is not in B. Well, B contains 0, 2, and 4, so I don't want those. So I want everything except those. So the complement of B is going to be 1, 3, and 5. So the complement of B then is just going to be 1, 3, 5. Now, here's another thing though. What is 1, 3, 5 though? 1, 3, 5 is A. So we can actually say, well, this is the complement of B is A. Right? So the complement of B is A. Okay. So now, C complement. The complement of C is everything that's in the universal set that is not in C. Well, C has 1, 2, and 3. So we want everything except those. So that means 4 and 5. So that means the complement of C is going to be the set that contains 4 and 5. Okay? Now, let's do the next two. And I'm going to erase this because I want to show you how you can think about those. Okay? Okay, so there's the sentence. Okay, so now, what does this say? Okay, so you gotta make sure you understand what this says. It says it's taking the union of A and B, right, and parenthetically. So it's saying I want the union of A and B, but I want the complement of that union. Okay, so this is saying I want the complement of the union of A and B. Okay, so let's draw a Venn diagram. Okay, so let's draw a Venn diagram to help us figure this out. So A and B, so here's A, and here's B, so A and B. So what's A? Well, A is 1, 3, and 5. And what's B? 0, 2, and 4. Okay? So A is 1, 3, and 5. Oh, so they're disjoint. So let's write it, let's do this correctly. Okay, so let's write it this way then. Okay, so this is 1, 3, and 5. So this is U, right? So this is A and B. So A is 1, 3, 5, and B is 0, 2, and 4. And then the universe has 1, 2, let's put 0 in here. Well, let's ignore the fact that 0 is not in here, because I think that's a typo in the book. But let's say this situation. So we've got 1, 2, 3, 4, 5. So that means 1, 2, 3, 4, 5. So it looks like A and B make up the whole universe, right? Okay. And we want to take the union of that. So what's the union of this? The union of A and B is I want everything in A and I want everything in B. Right? That's the union. So now that we know what this is, now I want the complement of that. I want everything that's not in the union of this. So I want everything that's not in this. Well, what is that? That's nothing, right? Because there's nothing outside of those. So that means that the complement of the union of A and B is the empty set, or the null set. Okay, let's do E. E is now what we're going to do is we're going to take the complement of the intersection of A and C. Okay, first of all, we need to know what the intersection of A and C are. So let's take A and C. Okay, so A and C. So here's A and C. So A contains 1, 3, and 5. Okay. And C contains 1, 2, and 3. And so here's the situation, because they both have 1 and 3 in there, so there's overlap there. So this is the situation. So what is the intersection? First of all, what's the intersection of A and C? Well, that's going to be this. So the intersection is going to, oops, hold on, just got to, and so what do we have? We have 4 is out here. Okay? So because we have the universal set. Okay? So now we want the intersection of A and C, which is 1 and 3, but we want the complement of that. So we want everything that's not in the intersection of A and C. Well, what's not in here? That's going to be 4, 5, and 2. So that's the answer. So the answer is the set of 4, 5, and 2. The order doesn't matter. Okay? So you can say 2, 4, and 5. Okay? And so that is, again, so that's how you handle those. Okay? Or hold on a second. Oh, you know what? I was right. There should be a 0 in here. I misread the problem. No, there is a 0 in here. 0. So 0 should be in here. So that means 0 should be in here. So that means yeah, that's fine. Yeah. So so that means that I just need a 0 in here. That's all. Sorry about that. Let's see here. Yeah, that's it. So yeah, that's it. Okay. Have a great day.